Hello everyone. So I've started the first chapter of class 12, that is electric charges and field, and in the first two videos I have completed some of the question answer of quantization of charge, and now we are going to start some question answer from Coulomb's law of electric force. Okay, so here we have the first question, that is obtain the dimensional formula of epsilon naught. Okay, so we know from Coulomb's law, we know F, that is Coulomb force, is equal to Q1 Q2 divided by 4 pi epsilon naught r square, where Q1 and Q2 are the charges, r is the distance between them, and epsilon naught is basically the permittivity of free space, right? So from here we can write epsilon naught is equal to Q1 Q2 by 4 pi f r square, right? So from this equation only we are going to solve the dimensional formula of epsilon naught. So epsilon naught is equal to charges Q1, the dimension of Q2, 4 pi is basically a constant, so we don't need that, and F, dimension of F, and dimension of R square. Now we know that we don't have any direct dimensional formula of charges, but we know that current I is equal to Q upon T. So from here Q is equal to IT, right? So from here charge, the dimension of charge is A into time. Okay, so here only we are going to write that charge Q1 is AT, charge QT also A into T, divided by, now the dimension of force, which is M L T to the power minus 2, and R square is L square. So here it would be A square T square divided by, it is M L cube T to the power minus 2, and the final would be M inverse 1 L inverse minus 3 A square and T to the power 4. So this is our final answer. So the dimensional formula of epsilon naught is this. Question number 2. Calculate Coulomb force between two alpha particles separated by a distance of 3.2 into 10 to the power minus 15 meter in air. So two alpha particles are separated by a distance of 3.2 into 10 to the power minus 15 meter in air, and we have to calculate the Coulomb force between these two alpha particles. Now we know that charges of these alpha particles are 2e. Okay, and distance is 3.2 into 10 to the power minus 15 meter. And from Coulomb's law we know that Coulomb force F is equal to Q1 Q2 divided by 4 pi epsilon naught r square, where epsilon naught is the permittivity of free space, right? Now this 1 by 4 pi epsilon naught has a value which is equal to 9 into 10 to the power 9 Newton. So first this is 2e into 2e, and the value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9 divided by r square, which is 3.2 into 10 to the power minus 15 square. So this is 4e square. Now E means the value of A is 1.6 into 10 to the power minus 19 Coulomb. So this would be 1.6 into 10 to the power minus 19 square into 9 into 10 to the power 9 divided by 3.2 into 10 to the power minus 15 square. And after calculating this, we will be getting 90 Newton. So this is our answer. So the Coulomb force between two alpha particles separated by a distance of this meter in air would be 90 Newton. Question number 3. Calculate the distance between two protons such that the electrical repulsive force between them is equal to the weight of either. Okay, now we know that for a proton, the charge of a proton is 1.6 into 10 to the power minus 19 coulomb, and the charge of the mass of a proton is 1.67 into 10 to the power minus 27 kg. Okay, now according to this question, the weight of one of this proton is equal to the repulsive force between them. Okay, so we know that Coulomb force F is equal to Q1 Q2 by 4 pi epsilon naught r square, and the weight of this would be mp into g, mass into acceleration due to gravity, right? So this W is equal to F. So mpg is equal to Q1 Q2 by 4 pi epsilon naught r square. Now from here we have to calculate the value of r. So r square would be Q1 Q2 by 4 pi epsilon naught mp into g. Now this Q1 is, the value of Q is 1.6 into 10 to the power minus 19 square, and the value of 4 pi epsilon naught is 1 by 4 pi epsilon naught is 9 into 10 to the power 9 divided by mass of proton is 1.67 into 10 to the power minus 27 kg, and g is 9.8. And after calculating this, we'll be getting 1.4 into 10 to the power minus 2. Okay, so from here r is equal to square root of 1.4 into 10 to the power minus 2. So this is equal to 0.0118 meter. Okay, so this is our answer. So the distance between these two protons would be this. Question number 4. How far apart should the two electrons be if the force each exerts on the other is equal to the weight of the electron, given that E is 1.6 into 10 to the power minus 19 coulomb, and Me, that means mass of the electron, is 9.1 into 10 to the power minus 31 kg. So this question is quite similar to the third question. So again, charge of the electron is given and mass of the electron is given. So weight of the electron is Me into G, and the force, that means Coulomb force, is equal to Q1 Q2 by 4 pi epsilon naught r square. So W is equal to F. So MEG is equal to Q1 Q2 by 4 pi epsilon naught r square. So from here r square is equal to, now here we are specifically talking about electrons, so we can write this as E into E, which is E square divided by 4 pi epsilon naught Me into G. Now the value of E is 1.6 into 10 to the power minus 19 coulomb square divided by, so 1 by 4 pi epsilon naught is 9 into 10 to the power 9 Newton, and then Me, which is 9.1 into 10 to the power minus 31 kg, and G is 9.8. After calculating this, we'll be getting it as 25.84. So R is equal to square root of 25.84, which is equal to 5.08 meter. So this is our answer. So the distance of these two electrons would be 5.08 meter.